you know her, you love her. Many of us have actually spoken about her today, like perhaps earlier when Chipperdoodle said, Chloe Mads is a champion? And it's so true! It's Chloe Mads!
Doctor?
My favorite bus dweller.
How you doing?
I'm well. How are y'all?
Really good.
We're doing a great we're doing a great time.
We're doing a great time.
We're doing a great
Doing a
time.
Great time.
It's only been many hours.
It's only been a few hours.
I'm looking at the thing. You've been here for 11 hours, or is that
We have
accurate?
been here for 11
Yeah,
hours, and it's
that
been
is right.
some of the best 11 hours of our lives.
Hell yeah.
And we're entering nighttime mode here. We got our LEDs.
Look at all of our fun lighting. That's how you know.
Also
we're
want to
cool.
say I love the sloth.
Yes, thank you.
And you're as a well, I guess I'm still a designer, but as an ex-graphic designer, I really love all the branding, and the poster is really cool too. I saw it all actually just today, and I'm really happy. I love it. It's really good work. So.
Amazing.
Hey,
Thank you.
It's always cool to have a game recognize game.
Hell yeah.
So, what have you been up to, Chloe?
Everything. I think I don't know how many. I mean, it looks like there's a few people in the chat who know me, but if you don't know me, I live. You may see already. I live in a school bus. Her name is Gary Bussey. I got her in 2020, and got really into using Home Assistant to automate things in my new home. Not so new anymore, but I realized that like smart devices don't. You got tons of smart devices. You could get a smart bulb in like a gas station these days, but that's really more focused towards like assuming that you're in a house with mains voltage, and there's not a lot of stuff for the DC side of things. And what I really want to focus on is taking as much off of the inverter as possible, because most of our devices are DC anyways. They have a conversion brick inside of them. So if we're inverting from our battery and then coming back down just to run a smart device, the ESP32 in a smart device seems wasteful to me. And so I've been on an adventure to wire everything as much as possible in my bus with DC based on the battery voltage that I'm using. I'm using a 24 volt system, but whether that's 12 volts, 24 volts, or 48 volts, I want like a standardized system to put all that stuff together. More recently, I launched a crowd supply. It's got a couple days left, but we are fully funded for the Power Tool 500. This is if you've ever been in a van or off-grid situation, you may recognize this as like a battery monitor or a power shunt. Basically, anything that goes through this brass shunt here will send a voltage to the sensor based on how much current is running through it. And this thing can handle up to 500 amps peak, 300 continuous. This is pretty standard for the low end of power shunts like this. So you put this something like in line with your battery, and then it can read in and out. The main thing about this is that it's running ESP Home and works directly with Home Assistant, fully open source everything. We can even take off the cover here, and so you have full access to the hardware. You have extra GPIO. And all of this is based off of microcontroller I came out with a couple years ago called the Flip C3. And it's basically just an ESP32C3 with a 60 volt tolerant buck converter on the back. Basically meaning that you can put this anywhere in any 12 to 48 volt system and have access to ESP32. And I ship them with ESP Home on them. So basically plug it in, give it power, and it's showing up in Home Assistant immediately. So you could do simple things like, a quick wire to, you have your quick wiring, and then you wire up some LEDs. This can handle the buck converter is 5 volts at 2 amps, or 2 amps at 5 volts. So that's about 100 LEDs right there. So quick deployment of like just addressable LEDs, really easy. And there's a little, I use the WS2812 that's on board as like a logic booster for the 5 volts that it kind of really wants, even though most of us makers have found out that like just getting it as close to the board as possible works with 3-volt logic. And then, since I definitely made a footprint on these that also passes the power between boards. So something like this is an example of a MOSFET set of MOSFETs for load control and PWM of lighting and stuff like that. So you can do your load switching, shed loads if you're running low on energy, or you can control lighting, dim lighting and whatnot. And that would just, the Flip C3 just pops on the back like that. This version is about 60 watts a channel, and I'm hoping that I can get this to be closer to 100 watts per channel. And then on the other end of that, we need something for our inputs as well. And this is just a switch panel, also a module for the Flip C3. And then these are dual throw switches. So you can actually push them up or down. So you can actually put, back to my user experience design days, you can put intent behind your action. So on being up, down being off. Here's an example of what that might look like as like a retail version of something that you can put on your wall or on your desk. And then since these are all just actually I2C modules, they're fully daisy chainable. So you have something like this. You can have something like this where it's actually a 19-inch rack with 4 of those switch modules. And that means you can actually just daisy chain from even the power tool or these on one single Flip C3 if you really want to. That kind of modularizes the system, makes it easy to say rather than having, a bunch of ESP32s to do different functions, you reduce your reliance on the processing power. Instead of just having tons of processing powers for simple tasks, you can, collapse that into a single processor where you need it wired, right? So that can contain a set of functions at a certain area. A fun little side project I did was on my way down. I just moved earlier this year, actually right at the beginning of this year. I moved to Joshua Tree, and I took Gary from the Bay Area down to Joshua Tree. And on the way, I had some electrical issues that completely killed my transmission, or the use of my transmission. I knew it was mechanically sound because I actually rebuilt it myself. So I did end up having to take back roads in second gear all the way from like San Bernardino up to Joshua Tree. But once I got there, I realized, this 30-year-old wiring of the front end of my bus is just starting to see age. And the Flip C3 being, having that buck converter on it means that it's also adaptable for automotive use. And in this case, I completely replaced my transmission controller with just this board and a Flip C3. And you'll find, if you ever done research on transmissions, they seem super complex, but that actually controlling them is actually pretty simple. Only 2 of these MOSFETs are needed to control the gearing of the transmission itself. It's a binary, 2-position binary. So 1, 2, 3, 4 to get through the entire range. So I can manually control my transmission now. Still working on the software to do automatic transmission. Still need to get more sensors pulled in here, but I just thought it was a good visual for people to understand that, hey, this isn't just for home automation. You can do more with these ESP32s and actually in my case we're extending the life of my bus rather than having to buy a 30-year-old transmission controller for $400. I got a few of these prototypes for like $100 minus tariffs, mind you. Um, Additionally, just even simpler stuff. When I first built the Flip C3, I actually loosely modeled it, the footprint, after this $10 Ethernet connector. I forgot about it for like 2 years. I just completely spaced. It was just sitting around. I was doing all the stuff that I needed to bring this, to the people. And then I tested it more recently and it works fine. You can even flip this around both ways. So depending on, your wiring layout, you have the wires going in the direction that you need them to go. I just need to document this, which I haven't yet. Realizing further than that is that it should be pretty trivial to make a version of that Ethernet connector with PoE, since we have the buck converter on board. PoE is 48 volts. We can easily buck that down to the 5 volts we need for the Flip C3 with that buck converter on board. Although Ethernet it would be trivial if Ethernet was trivial, and there's a lot of research to do before that actually becomes a reality. More recently, a bunch of my friends do wearable stuff, and I've been trying to come up with ideas on what to do with single cell batteries. A lot of my work is done with multiple cells, like anything 2 in series or more is really where I'm at, usually at least 3 or 4 in series or more. But and previous to Gary, I was living in a van, and I was making I didn't have a lot of money, so I'd buy old battery sets, or find drill batteries, laptop batteries and stuff. And at that time, it was pretty easy to just take a bunch of 18650s and put them in series and parallel and make your own battery pack. Although it doesn't really make much sense anymore, 5-6 years later, considering how low battery prices have become, and lithium ion versus lithium iron phosphate being much more stable, much safer to deal with, and you can get bigger cells that where you don't necessarily need to double up anymore, and use hundreds of cells. You use 10, 4 to 16 cells, where you normally use several hundred to create something with 18650. So I've been trying to find a way to use single cells for scenarios, so we can reclaim these, and rather than this ending up in a landfill once it's found its use. It's still a good battery. Thing is, a lot of people don't realize, we have positive and negative, but what a lot of people don't realize is that the whole outer case of an 18650 is actually ground. There's this big jelly roll that they put in here, they compress it, they shove it in here, and they crimp the tip, and then they wrap it in insulation. If we get rid of this insulation a little bit, do this live on camera. I did this 100 times at Maker Faire and Teardown. We just take that crimp area and we pop off, I call this circumcision, we pop off that foreskin of insulation. We actually have positive and negative right there in plane. So I can even take this and hopefully create a spark for you. Yeah, there we go. And that means we no longer have to pull ground from the bottom, and we can actually take a simple little thing like this. It's a 3D printed cap with a custom circuit board in there, and that goes right on top. You push that in a little bit, and then you can see the one LED right there. That's actually one of 4 if this battery is low, but that becomes a little USB-C battery bank. Each of those USB-C ports can either charge or discharge this battery. This is the version 2, and I'm really happy with this. But version 3, I'm hoping to make self-tapping. So I don't necessarily want to make people who buy this, or my customers, necessarily have to circumcise their cells. I feel like that's a dangerous thing to, some people might be okay with doing that, but I think that's a dangerous thing to like hand to a normie. And so V3 is going to have self-tapping, better phone support. We don't currently have like full phone support. There's a weird old fast chart spec where D+ and D- need to be tied together. And these ports that I used don't have the data pins in there, so it won't work for an iPhone, and some USB-C phones don't actually work as well. So I'm working on that. And V3 is also, so I made additionally, thank you, Chippy. Additionally made a flashlight accessory that goes in there. Oh no, that one's broken. Let me grab a working one. This has a little flashlight accessory. I'm gonna actually build that into the next version, and I think as like a multi-tool EDC thing, this thing just, I don't know, this product just came together really well, and I'm really happy about it. First version actually worked. Second version was just like a cleaning up of, refining things. And that's the one that I took to teardown, gave a whole bunch of people these and did the demo right in front of them. Got a lot of good feedback, and I'm realizing what I need to do for V3 and understand how to finally bring it to the market. I think that's my ramble. If y'all have any questions.
That was amazing.
That was wild.
We were literally sitting here like, wow, Chloe's living this like wonderfully strange scavenger lifestyle, just popping things off batteries and getting in there and seeing what's going on. And I'm nervous because every time I plug in something in this one socket in my house, it shocks me. So
you should be a little nervous about that.
Oh,
yeah, no, absolutely.
Yeah.
You need to get that outlet grounded.
I don't know. You're rightfully nervous.
I think I need to talk to my landlord.
Well, your landlord now.
My landlord email.
Well,
joining us,
yeah, thank you so much. It's always so great to hear what you got going on.
We always love to hear about Gary Bussey. We love that guy.
All right. Well, we'll talk soon. Thank you.